Welcome to Trigo Graphs. This series will provide information, discussion, and illustration on the graph of trigonometric functions and their corresponding versions. To start, we have here a function y is equal to sine x, where x is between 0 to 2 pi. We are going to graph that here on this Cartesian plane, where the horizontal axis corresponds to your x values and the vertical one would be for our y. By a graph of a function, we mean a set of points, and only those points in this plane corresponding to the ordered pairs of the given function. Thus, the graph of y equal to sine x is a set of points whose coordinates would be x and then sine x, right? Then, we are going to satisfy the equation which defines the function. Take note that our x is between 0 and 2 pi, so we're going to use here the special angles for a unit circle to identify the corresponding ordered pairs. So if we have here x, and then y, let us assign here the special angles for our x, starting with 0 degrees. As we try x being 0 degrees, sine of 0 is also equal to 0. That's the first ordered pair we're going to plot here on our Cartesian plane later. Next would be the special angle for 30 degrees, or in pi radians, pi over 6. And sine pi over 6 is equivalent to 1/2 or 0.5. Okay? The next special angle is pi over 4, or equivalent to 45 degrees. And the equivalent for sine pi over 4, or sine 45 degrees, is actually square root of 2 over 2. Let me extend that here, because we need to continue this to the next special angle, the 60 degrees, or in pi radians, pi over 3. Sine pi over 3 is equivalent to square root of 3 over 2, or approximately 0.87. Next to be followed with the 90 degrees, or pi over 2, which would give us a value of y being 1. Okay? So this would be the first set of special angles together with the corresponding value for y. So we are going to continue this with the next special angles. We will have here 2 pi over 3. We'll have 3 pi over 4, 5 pi over 6, and you have here our pi. And we will have the corresponding values. If you would like to try that, you will have here square root of 3 over 2. You will still have square root of 2 over 2. This is actually equal to 1/2, and you will get here 0. This would be the set of values until pi. But since we are to end up at 2 pi, let's consider another set of values here. Let's have for x, and you will have here the values for your y for the rest of the special angles. The next special angle that we can use here is actually 7 pi over 6. 7 pi over 6, or equivalent to 210 degrees. Sine value of that is equivalent to negative of 1/2. Okay? It's actually in the third quadrant. For the value of y becomes negative. But take note, the value of x here corresponds to the angle we used. The next special angle here is, of course, what we know as 5 pi over 4. This is equivalent to negative square root of 2 over 2. To be followed with 4 pi over 3. And the equivalent value for the y for that is square root, or negative square root of 3 over 2. We will reach here another special angle on the y-axis, which is the 3 pi halves, or the 270 degrees, which would give us the value of y equivalent to negative 1. If you're going to continue this, you will get the next value of 5 pi over 3. You will have here the next value 4, 7 pi over 4, then to be followed with 11 pi over 6 before you will reach 2 pi. And the trend for the values would be this values. Negative square root of 3 over 2, negative square root of 2 over 2, you have negative 1/2 before you reach again 0. This would be the set of values from 0 to 2 pi. And let's plot them on our Cartesian plane to see the form of the graph of y equals sine x. Now, take note here that we are using radian measurements for x. And the possible values for your y would be actually values in numeric forms. So you doesn't necessarily be strict with our values on our x and y axis to be of the same quantity or the same ratio, you can actually try here using 2 pi for our x, and of course the maximum value for our y values would be 1 and -1. So allow me to assign 1 somewhere here and -1 here. Now, to complete with our x axis, of course, half of 2 pi is, you will have here your pi. To be followed with half of your pi is actually pi over 2. And you will have here 3 pi over 2. Take note, we have other special angles, so you can also try to assign them. Take note that this is actually pi. To get pi over 6, you'll be dividing that into 6 parts. So your pi over 6 is somewhere here. It's pi over 6, so you will have to divide it something like that. Your pi over 6 is somewhere here. This is your pi over 6. This is your pi over 4, and this is where you will see your pi over 3. Okay? So, continuing all those rest of the forms. So, I might not be writing all of the notations here because this might be too compressed here. So, basically, you will have this marks for the rest of your special angles. And of course, let's try to plot them one by one. The first one is x0, y0. You will have this point here. Okay? The next one here is, let me use this color for our pen. Black. Okay? The next one will be pi over 6 and 1/2. So it basically somewhere here. Assuming that my pi over 6 is actually accurate. Next to be followed with is pi over 4, which is square root of 2 over 2. Or that is actually equivalent to 0.71. So more or less, it's somewhere here. 71. Okay? For pi over 3, that's actually equivalent to square root of 3 over 2 or 0.87, approximately 0.87, so somewhere here. Okay? Then, for pi over 2, our, this one here, pi over 2, our y is equal to 1. Okay? So you would see there's a trend going up. If we're going to plot the next, 2 pi over 3 somewhere here. Okay, because we have the same value, 0.87. So you will have the next one, which is 3 pi over 4, which is this one here. You will have this value, 0.71. And you will have 1/2 for your 5 pi over 6. Then for your pi, you will be reaching 0. So you would see a trend of going up and going down. But this actually have a certain curve. So it might not be actual to be seen in if we're going to consider appropriateness of the points or marks at the x-axis. So this is the first part of our graph. You will have here this form. Hopefully I could connect them right. So you will have here, assuming that I have connected them right. Sorry for that. Let's do it again. Okay. So you will have this first part until pi. But take note that our graph should extend until 2 pi. So let's plot the next few values. And we know that it's the negative values now for our y. So you will have here -1/2. You will have here -0.71, so somewhere here. Next will be -0.87, so somewhere here. Then you will have -1 for 3 pi over 2. Again, look at the table of values. You will have -0.87, -0.71, -1/2, until you will reach here 0. So by connecting them, it would actually look like this. Hopefully I could make this right. Okay. So connecting them, sorry for that. Okay. Since we end up until 2 pi, this is the actual form or the basic form for the graph of a sine trigonometric function from 0 to 2 pi. So this is its graph. So it more or less, your hint here, it looks like an S in its special way. So when you talk about the graph of sine, it will be like this. But for different versions for sine, as long as it's sine, they will have different targets, different periods, different heights, as we are going to discuss them as well later. So stay with us as we are going to graph another functions later on. In the meantime, subscribe to our channel.